Hello everyone, my name is Sanika Uttam Kadam and today I am giving presentation on the topic dynamic characteristics of the MOSFET. So for that firstly we have to know what is exactly MOSFET. So MOSFET is just type of the transistor. MOSFET means the metal oxide field effect transistor. MOSFET is voltage control device, means it has the small amount of current that is equal to 0 or negligible also. Switching speed of the MOSFET is high in nanoseconds only, and the application of the MOSFET is in low power high frequency converters. So as we know, MOSFET is the fully controlled device, means controlled on and the controlled off. So let's see the classification of the MOSFET. So MOSFET is basically classified into two types. First is the depletion layer MOSFET and next is the enhancement MOSFET. So it is again classified into two types, that is N-channel MOSFET and P-channel MOSFET. So as we know, MOSFET has the three terminals, that is the gate, drain and the source. ID is the drain current and VGS is nothing but the voltage between gate and the source. So VGS, that is the voltage between gate and the source, it can be positive and also negative. If VGS is positive, then IDS is increases, and if VGS is negative, then IDS is decreases. That is the N-channel electron repleted and depletion layer is created. So this is all about the N-channel MOSFET and the P-channel MOSFET. So let's see the dynamic characteristics of the MOSFET. So these are the two diagrams related to the dynamic characteristics of the MOSFET. So first diagram indicates MOSFET before applying voltage and second diagram indicates the MOSFET after applying the voltage. So in second diagram, as we see, input voltage is applied to the gate terminal. Gate to source voltage is steadily increased. So it can be indicated by the line, first line, and then it becomes constant. The straight line after first line, it indicates that the constant voltage. And when gate voltage is removed, that is the when gate voltage is 0, the gate to source voltage is steadily decreased. As we can see is in the second diagram's last line, the voltage is going to be decreased. While focusing on the turning on and the turning off, there are four particular time parameters considered to be understanding the switching methods. As we see in the diagram, there is the TD on, that is the time delay on, TR, that is the rise time, TD off, that is the time delay off, and TF is the fall time. So TD on is the time required to change input capacitance to threshold voltage level. This is the time taken to make sure input voltage equal to the threshold voltage of the MOSFET. So the minimum voltage used to trigger transistor across the gate is threshold voltage, and transistor is only turn on if input voltage is equal or greater than the threshold voltage. So the moment gate source voltage becomes equal to the VT, transistor will turn on. So next see the rise time. What is the rise time? The gate charging time from threshold level to the full load voltage VGSP, which is required to drive transistor in linear region of operation. Then VGS is equal to VGSP equal, then voltage becomes constant. So during turn off, gate voltage is the 0. So in turn off there are two situations, that is the TD off, that is time delay off, and it is the time required for the input capacitance to discharge. So gate to source voltage falls from VGSP to 0, that is the fall time. So let's see the importance of the dynamic characteristics. So first importance is the high speed switching, in which essential for the efficient power conversion in inverters, SMPS and motor drives. Second is the reducing switching losses. Lower switching times and the capacitance improves efficiency. And next is the heat dissipation. That is the faster switching reduces the energy loss and heat generation also. So these are the some definitions of the time related parameters. So first is the TD TD on, that is the turn on delay time. The time applying the gate voltage and drain current starting to rise is the TD on. Next is the rise time. The time for the drain current to rise from the 10% to the 90% of its final value, it is the rise time. Next is the TD off, the time between removing the gate voltage and the drain current starting to fall is the TD off. And last is the fall time, the time for the drain current to fall from the 90% to 10% of its initial value is the fall time. So this is all about the dynamic characteristics of the MOSFET. Thank you.